To get started, let's talk just about how to define objects and instances in Python. We've actually already seen this in some places, but we didn't refer to them by these terms. For this, let's stick to our running person example. A person should have a first name, a last name, an eye color, and an age. We'll represent the names and eye color as strings and the age as an integer. So here's how we would define our person class. We start with the keyword class. It's red and bold to indicate it's a reserved word in Python. And then following that, we give the class its name. In this case, the name of the class is person. So just like we use def and a function name or a method name to define a method or a function, we use class and a class name to define a class. As with most of our structures, we end with a colon to indicate that the following code will be indented. All the code indented under the keyword class is part of that class. So what do we see next? Well, we see a function. Well, actually, technically, we see a method because we're inside a class. And remember, methods are just functions inside classes. This method has a strange name, though, __init__. And it also has a strange parameter, self. We'll talk more about this method later, but for now, what you need to know is that init is called when we first create a new instance of this class. So whenever we create a new person, the very first thing it does, while creating it, is it calls this method and runs whatever code is contained within it. That's why it's called init. It initializes an instance of that class. So think back to when we would define strings. The string class actually had an init method that was called whenever we created a new string. All it does is it executes some code that will be needed for the rest of the program. So here, when we create a new person, we want to give it some default values for first name, last name, eye color, and age. Our default values are meant to emphasize the fact that no real value has been assigned. Hopefully no one has these names, and no one should be -1 year old. So like I said, when a function is defined inside a class, we call it a method. It still works the same way though. Whenever this method is called, the lines of code indented under it are executed in order. So here there are 4 lines, and notice that each line starts with this keyword self. Self is a little bit strange. It tells Python to define these variables for the instance as a whole. In other words, any other code inside this class would be able to see those variables, as long as it accessed them with self as well. And they persist even after running this method is done. If we left off self, then the variable age would cease to exist at the end of this method. But because it starts with self, the variable age exists as long as this class or this instance exists. So writing self.firstName basically says, anytime we look at this instance's first name, it should be the same one. Every method defined inside a class should have self as the first parameter. We'll never have to pass in an argument for it though. Self by default just sees all the variables associated with this instance of the class. Now everything I'm saying might be a bit confusing right now, and in fact I'm kind of confusing myself even trying to explain it because these are kind of weird in the way that they operate. Don't worry too much about understanding them declaratively just by being able to describe the way they work. Instead, just focus on learning to use them. As far as learning to use them is concerned, just know that you should use self inside of a class anytime you want those variables to either exist after the function is done running or to borrow from functions that have run earlier. Now, defining a class works a lot like the functions that we've seen in the past. Seeing this line, class person, just tells the computer, hey, you need to know the concept of a person. Right now, you don't actually need to create any people, you just kind of need to know what a person is. And later on, we might actually use this concept in our code. So think of declaring a class kind of like teaching a person a concept. If you knew someone wasn't familiar with books, for example, you would teach them that every book has a title and it has an author, and then when you give them a book, they know to look for the title and the author. Teaching them the idea of a book having a title and an author is like declaring the class. We tell them that when you encounter a book, you should expect it to have a title and an author. They haven't encountered a book yet, though. They just understand the concept of what a book is. Then, handing them a copy of Introduction to Computing by David Joyner is like having them create an instance of a book. They knew what the concept of a book was, but now they actually have a literal book. That's an instance of the general idea of a book. Now, once defined, though, classes work like any data type. You can use them as values in lists or in tuples. If some of their variables are lists, you can loop over those lists. You can even use classes as values for other classes. So for example, we could create a second class to use here. Instead of defining a first name and a last name just as variables that correspond directly to a person, we might instead create a class called name. A name contains a first name and a last name, and then a particular person has a name. That probably more closely matches the way we think about names. If I ask you what my name is, you say my name is David Joyner. If I ask you what my first name is, you say my name is David. David and Joyner are parts of the general idea of a name. We can use this to create extremely complex data structures that are nonetheless not difficult to use because everything is organized in logical ways that mimic the way we think about the real world. That's the real power of object-oriented programming. It allows us to write programs that mimic the way we organize our knowledge of the real world.